So 4.2 is called the law of cosines. Generally speaking, a problem will present itself that it needs to be using either the law of sines or the law of cosines to start. You don't just get to pick. So in particular, the law of cosines happens when we actually have an angle. We either have three sides, right? There's no angles given at all. That's one option. Or we end up having like that last problem was that we saw where we don't have an angle side pair that match, right? Like we don't have an angle A and a side A. So if we don't have that piece of information, it's easy. This is one of those things that's easier to define it by what you don't have than what you do have. Then the law of cosines becomes an option. Now, if you take a look at the law of cosines, it's very similar to the Pythagorean theorem. Do you see these pieces? They're just like the Pythagorean theorem. In fact, the one that you know and love is this one down here at the bottom, right? A squared plus B squared equals C squared. Flipped around, but otherwise that's what's there. So what happens is we have this extra piece on the end that's minus 2ab cosine C, okay? So let me kind of, because you're going to have them memorized, let me kind of remind you of how, not remind you, but show you maybe of how I think about them in terms of a mnemonic device. So clearly the three sides can go in any order in terms of the left hand and the right hand side, right? One of them's on the left, the other two are on the right. And then the subtraction piece is always double, and the two pieces over here, B and C, are the pieces that match the side that you're on. Okay, so B and C are on the right, so it's B times C with a 2. And then you have the cosine of the angle that's on the left. And all of the three of those versions of this formula are the same in that regard, right? So let's just look at the last one. So you have your A and a B on the right. So it's AB right here times the 2. The C is the cosine of C, where the C is on the left. Okay, so the formulas always go the same direction. And then the rest of the things that are written around here are sort of the descriptive pieces of what this formula is doing. It's the square of a side of a triangle equals the sum of the squares of the other two sides minus their product times the cosine of the included angle. Yeah. Another way that you can think about this, especially if you've got a picture drawn that works really nicely, is that this formula works. Let me put A, B, and C in here, and let me label the sides. This works when you have two sides and an included angle. Okay, so if you see a picture version of this, it's also sometimes easy to discern that this is law of cosines because of that setup. Two sides, A and B, and the included angle, right? The angle that's between them instead of across from them. All right, so let's take a look. Oh, you know what the best part is about this? There's no ambiguous case. And the reason there's no ambiguous case is think about what happens in quadrant 1 with cosine. Cosine values in quadrant 1 are all positive. I mean, that's true for all of our trig values, right? What can you tell me about cosine values over here in quadrant 2? They're negative. They're not the same. See, that didn't happen with sine, right? Sine values had mirror images in the quadrants 1 and 2. Cosine doesn't have that happen. So I never have two options for these triangles. That said, I do want to be a little bit careful that I don't accidentally do something wrong, perhaps, and there is a way that I can do that. I'll mention it when there's a possibility so you can see it. But there should only be one triangle if you're ever using the law of cosines. All right, so let's take a look at one. So we're going to solve the triangle. Remember, solve the triangle means find all the missing sides and angles. And we're going to round the lengths of the sides to the nearest tenth, angle measures to the nearest degree. That's going to be our go-to every time, okay? It'll be written on all the quizzes and the tests, but reminder, angles nearest degree, side lengths nearest tenth. All right, so we have angle A is 67, side B is 8.9, and side C is 7.2. And I know this works with cosine because this says as an angle A, and then I have a side B and C. They don't match, okay? So I want to start with the left-hand side having side A on it because I have an angle A that's given. So this is A squared equals, the other two pieces, B squared plus C squared, are on the right, minus 2 times the pieces that are on the right, B and C. I said it and wrote it wrong. Let's try again. B and C. And then it is the cosine of A. Because we've just done the law of sines, you might be tempted to just write down sine, so be careful, right? It is cosine when we have the law of cosines. And we're going to put the pieces in that we have. So we don't have A, so we'll leave that one in there as a variable. B is 8.9, so this is 8.9 squared, plus C is 7.2, so 7.2 squared, minus 2 times A, 8.9, I'm sorry, B, 8.9, C, 7.2, and then cosine of the angle A, which is 67. Now, you can flat out enter this in from left to right in your calculator as long as you're being careful with parentheses and those sorts of things. A lot of your calculators will handle this just fine. Don't hit enter right here. If you hit enter right here, it's going to calculate all of this and then multiply it by cosine 67. That's not what this says. The cosine 67 degrees is actually multiplied by this piece, right? All of this is being multiplied. So depending on the kind of calculator you're working with, it also might be helpful to just write down some of the pieces. So I actually have some of them written in, so I'm going to write them in. So 8.9 squared is 79.21. 7.2 squared is 51.84. And then the last piece, putting it all in together, because it's all multiplied together, makes a lot of sense. And if we do that, I get 50.0761. Okay? Not all calculators interpret pieces quite the same. So if we add the two first pieces and subtract the third, we end up getting 80.9739. And this is equal to a squared. So what does it mean I need to do then? Take square root. So what is the square root of 80.9739? Rounded to the nearest one decimal.
8.9. No, 9.
It is 9 actually. Yeah, if you round this one, it actually rounds to 9.0. So this is 9.0 and our units on this one is meters. So we'll put meters in for this. Okay, so this is the case that's the easiest to work with. I'm given an angle included between two sides, and I'm finding the opposite side. This is the simpler of the two options we're going to look at. I would like to encourage you at this point to write down what I'm going to write down. This is very important. The next step is that we're going to always, okay, so maybe I should just mention, we're not done with this problem, right? We're supposed to solve the triangle, so we have to find all the angles and all the sides, right? We now have all the sides, but we're missing two of the angles. One of the angles is going to be really easy to find because it's just going to be a subtraction feature at the end, but this next angle we actually have to work for, okay? So as we're taking a look at this, the next step here is where it's important to pay attention to what you're doing. We're going to always find the smaller angle side pair next. And we're going to do this using the law of sines. Now, could you use the law of cosines? You absolutely could use the law of cosines here. You definitely could. But what we're going to find out here in a moment is that using the law of cosines to find an angle is harder than using the law of sines to find an angle. So we're going to use, at least I'm going to show you how to use on this one, the law of sines to find the next angle. So taking a look, we've got side B is 8.9 and side C is 7.2. We need to use the smaller one. If you use the larger one, it might be just fine and you might get the right answer and it'll be okay. But it also might accidentally put you into the case where your calculator and you think that you have something that you don't because it's going into the ambiguous case. So it is possible, the reason is that it is possible that the bigger angle, 8.9 here, could be creating an obtuse triangle. And the law of sines only finds obtuse triangles when we look at arbitrary or at the ambiguous case. So I can just simply avoid having to think about it if I just start with the 7.2. So I'm going to start with the 7.2 and then I won't have to worry about it. Okay. So doing this with the law of sines then is that I have the side angle pair. So I've got sine of 67 degrees. Whoops. And I found out that that side length was 9. And this is going to equal the smaller value, which is 7.2, over the sine of its opposite angle, which would be C. And we will cross multiply. So I have 9 sine C equals 7.2 sine of 67. And we'll divide by 9. So the sine of C is equal, and I'll write down several decimals here. So I have 7.2 sine 67 over 9. So this is about 736,404, or something like that. And to find this, we would do the inverse sine of this value. Or you can use the exact version that's in your calculator too. Remember, our angles are going to be to the nearest degree. Mine says this is 47. Does yours say 47? Yes? Okay, good. So then you don't do more work than you have to. Do I need to set up an equation to find angle B? Not a full like law of sines kind of equation anyway, right? No, I mean, if I have two angles, what do I do, Beck? Yeah, absolutely. So I'm just going to take my angle A that I'm my angle B that I'm missing is going to be 180 minus the 67 that I was given in the original one, the 47 that I just found for angle C. And if I do this, I have angle B as 66. So this is an example of one that if I had found angle B using the law of sines, it would have been just fine because angle B is acute and it wouldn't have caused any problems whatsoever. But I can simply avoid the possibility of any problems by doing it in that order. Okay? All right, so I mentioned this is the easier case. And what I meant by that is that it's easier to find a missing side, which is what we did. We found side A, than it is to find an angle. Okay? So let's take a look then at what it looks like then to find an angle. So we can use the law of cosines when we have three sides given as well. Okay, I cannot use the law of sines at all. There's no way to do the law of sines with this information. There's no way of doing the law of sines from the beginning of this with this information either. It's not possible. I don't have a side pair. I don't have a way of finding a side pair. I can't use the law of sines. So when I'm taking a look at this one, I've got three sides. We have side A, side B, side C, okay? Now, we're going to put another note in here for what happens and which one we should find first to avoid any accidental ambiguous case showing up that doesn't really exist. And so while over here we wanted to do the smallest side first, right? That was our goal. Everybody with me? We're going to do the opposite on this case. We're going to find the largest angle first. So I'm going to put this note in here. Hopefully it goes into your notes as well. When given side, 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 which I am given here, we're going to find the larger angle side pair first. So what I mean by that is whichever side is the largest side is going to go on the left. So which of those values is the biggest? It is C. So the formula that I'm going to use on this one is C squared equals A squared plus B squared minus 2AB sine C. This is the form I'm going to use. I'm going to find the side C's angle C, first. Now, if it's not obtuse, then again, this is sort of like not really all that necessary. But if it is obtuse, it means that I'm not going to have to worry about the other two pieces. I'm automatically going to get acute angles. It's going to work out very nicely. I can, sort of like get that angle that's obtuse off my chart, off my list to start with. All right, so we have side C, which is 62.7 squared. Side A is 42.9 squared. Side B is 37.6 squared. Then I have minus 2. A is 42.9. B is 37.6, sorry. And then I have, look at that, I even wrote sine. Look at that. That should have said cosine. If you wrote that along with me, please change that. Cosine of C. I told you we've been working with sines and we just want to sort of just keep going with them. Okay. Now, this problem is actually showing very much why I kind of wrote out all the little pieces squared last time. The tendency people have is to try to put all of this in their calculator as though you can combine them, and you cannot, because this piece right here is a multiplication factor on the cosine C. These are multiplied. We multiply before we add and subtract, right? Order of operations way back when. So we have to be careful that we don't simplify things that can't be simplified. So we're going to find each of the pieces independently because I think it will keep us on on track without missing any of the pieces. So on the left-hand side, if I square this, I actually have 3,931.29. 42.9 squared is 1840.41. We're going to hope there's no typos in my notes. If somebody finds one, please stop me. And then I have 1413.76. And then we're going to multiply 2 times 42.9 times 37.6. Okay, those pieces get multiplied together. If they do, we have 3,226.08, and then I have the cosine of C. Okay, is that okay? Any questions right now? Okay, so I can add these two together, right? But I cannot subtract this value from it. Okay? Some of you are looking at this and going, why is she harping on this? I'm harping on this because people forget as they start moving through this, and they just want to keep moving, numbers together. So be careful. Don't oversimplify something that can't actually be simplified. So we're going to add the 1840.41 and the 1413.76. I have 3,254.17, and I'm going to subtract that to the other side. So this is minus 3,254.17 when I subtracted these to the other side. All right, everything else stays the same. Fantastic. And when I subtract, let's see, it looks like I have 677.12. Okay, does that look okay? I mean, I didn't ask if it looked good, but does it make sense? Okay, what would my next step be then? What do I need to do? To divide. Yeah, I'm going to divide now. So I'm going to divide by that negative 3226.08. So my negative 3,226.08 gets divided. So my cosine of C is left on the left. And again, I'm going to write this down I'm going to use 6 decimals because I want to be really careful I don't miss something. It's 209, it's negative, and then it's 209,889. All right, how am I going to find C? Yeah, we're going to do the inverse cosine. So C will be the inverse cosine of negative 209,889. And rounded to the whole number of decimals, right? Rounded to the whole number, no decimals. My inverse cosine of 0.209889. I didn't get a negative in there. Make sure you get your negative in there. Is 102. So this is actually a really good example of one this time where finding that that's an obtuse angle to start with is really helpful. Because what it means now is it doesn't matter which angle I find next at all. They're both going to be acute because you can only have one obtuse angle in a triangle. So let's find that angle that's missing, and then we'll find our third angle, and then we'll be done with this particular problem, and we'll finish next time. So I'm just going to go with side A at the beginning now. So the 42.9 over sine of A will equal the 62.7 over the sine of 102. Was it 102? Yeah, 102. So we can cross multiply. This is the 62.7 sine A is 42.9 sine of 102. And I'll divide by my 62.7. So the sine of A with 6 decimals is 669,259. And then how do I find angle A? Inverse sine, yep. And it should be 42 degrees. Okay, so how are we going to find side B? Angle B, excuse me. Just subtract 180 minus the 102 and the 42. What is angle B? Should be 36. Okay, it is more work to find angles, right? Like think about it. Look at the left-hand part. Do you see the left-hand part for finding angle C and the right-hand part for finding angle A? Right? The law of sines to find angle A is much preferable. You can always use the law of cosines if you want to as a secondary step, but there's not a need to do so.